and I'm Decrepitation. I'm an electrical engineer at Redefining. And it's great to see some amazing faces here. So we will discuss about neodymium iron bronze magnet manufacturing with high automation and with integrated sintering technologies. So first, let's discuss about our company. Brief overview about our company. We are a Chinese company based in Guangzhou. The name of the company is KAIYUAN Automation. It's one of the key player in the field. We also have individually developed decryptation, hydrogen decryptation furnace and resin technologies. So here are some of the overview of our R&D excellence. We have to go for 38 patent applications, including 11 innovation patent and 2 PCT innovation applications. And we have a huge market in China and also worldwide. We have a global footprint with countries like United States, Japan, South Korea, Vietnam, Taiwan, also India. And we are also a strategic partner with some of the big players in domestic China, such as Sinich Star Groups, GEL, Anhui, Art and others. So here are our production line. So with the picture, you guys can have a brief overview of our production line and also our cutting-edge technologies. So for the content for this presentation, we'll mainly focus about 4 parts: industry challenges in the magnet production, one-step forming, multi-cavity and the cylindrical production, and Press-Sintering Integration. So for the first one, we will mainly focus about the industry challenges, that what kind of challenge industry faces for the traditional magnet manufacturing. So here you can see that for a traditional magnetic manufacturing technologies, you have to go through a lot of steps, such as magnet forming and packing. Then you have to do vacuum sealings. You have to go to the process, oil filtering, peeling the outer layer of compact, filling in plastic, arranging in the frame. It's very costly, labor intensive. Also, it's like a very slow process. So here you have a real life example, a factory producing 45 tons a day, requires like roughly 197 people. Only for pressing, 105 peeling workers and 51 sintering workers, including mold and maintenance stuff. So the production process becomes very, very slow. It's roughly 120 kilogram per person daily capacity. So the industrial pain point, I just mentioned that it puts a big quality risk on the finished product, such as when you do CIP process, you can have oil contamination on your pin compact. Also, it's very costly. You have to go for buy some costly vacuum bag, and also we need lots of labors for the process. And CIP-based process has a very low automation because it's very, very difficult to integrate automation in the CIP process. Also, we have a lot of post-sintering instances. So this is our solution. What we do, we cut off we totally eliminate manual packing while CIP and peeling. So it reduces the manufacturing cost. So you no longer need plastic single baggage. Also we integrate the multi-cavity production in our production line. So on single time, you guys can press multiple magnets. And also what we did, we integrated press and sintering furnace. So you no longer need to transport the green compact from after pressing to the sintering furnace. What it happens like when you press the green compact and you transport to the sintering furnace, during the transportation, the green compact might crack or it might have some deformity. So when you do sintering, it drastically reduces the product quality. So we totally eliminated that. We integrated the pressing and the sintering furnace together. So our entire plant, we name it One Step Forward. It's totally developed by KYMAG, our company. So this is our standard pressing machine. It has a dual pump to vacuum the air from the machine, and we have dual motors for the pressing, controlling the pressing. It actually has a very compact design. The machine itself is not very big with immense power. Also, it's very convenient. Like it has some convenient platforms, so it's very easier to operate. So here are the innovations in the one-step forming machines. So we totally, as I mentioned earlier, we totally eliminate the blasting, wrapping, or spilling of CIP. So what you do, our main problem is oxygen. So to reduce the oxygen contamination, what you do, we use special kind of lubricant called JK6 binder. It's drastically reduce the powder activity, improve jet filling, also improve the quality. And here we have a brief overview of our magnetic field automation press. It's very fast and uniform product filling. What we do, we use a vibrator. As I mentioned earlier, we use a multi-cavity, so we use a vibrator to make sure that every cavity has uniformly powder, and also it has dual motor servo-control. This has the control pressing speed and variable pressure demolding. So the machine has very precise demolding technology. So we have a small video demonstrating our machines. So we transport the green compact by using an automated guided vehicle to the sintering furnace, and then we stack all the components in the furnace. It's totally automated without any kind of hand touch. So one-step forming, the key advantage of one-step forming is like very fast. For the pressing, our press, it takes 25 to 35 seconds. Actually, it depends on the magnet size, also the magnet shape. But standard, it takes 25 to 35 seconds. It has very excellent stability, low servo motor control, and it has very low energy consumption, 0.06 kilowatts per hour per pace. Also, it consumes very less nitrogen during the process, only 4 cubic meter per hour. Right? And for the mold changing, actually for the press, mold changing is very heavy. Like other places, like you need special equipment to change the mold. Also, you need like high level of skill, expertise in this field to change the mold. But for our machine, the mold change, it doesn't require some special equipment. Like within an hour, you just can change the mold. And it has significant material saving. Like the wastage is very low. The wastage is roughly about 50 to 100 grams. So, and it has like large pressing capacity. The maximum size of the magnet can be around 1 kg. Like single press, it can produce 1 kg size of magnet. And the green density can be very densely. Like the pressing, after the pressing, density can be 0.43 gram per centimeter square. So here another video demonstrating the pressing. So this is the finite element analysis inside our pressing machine, the place we place the magnet here. So, and this is the real life side view. This is our plans, and we have some 3D sketch about once you forming the equipment site. So this all are our equipments. So we, as I mentioned earlier, that we use multi-cavity, and our multi-cavity can produce cylinder and also blocks. So the key features the key features are including improved powder uniformity. So we use the vibrator to uniformly feed the powder in the multi-cavity molds, and also it's very, as I mentioned earlier, it's very flexible. It's we can rapidly change the molds, and it's very precision and consistency dual motor. And after the pressing, the weight division can be for the blocks it can be less than 1%, and for the cylinder it can be roughly 5%. And it also has a variable pressure demolding. For the main problem is when a pressing machine tries to demold, it can crack the green compact. But we use a air demolding system, so it doesn't make any cracks. It releases the green compact very easily after the pressing. So for each press, like for the cylinder, it takes roughly 36 seconds, and for the blocks, it takes around 45 seconds. So here we have some videos about the pressing. We are into section 4, and this is, I guess, one of the most important parts. And so what we did, as I mentioned earlier, we integrated the press and sintering furnace together, and it's the ultimate automation solution. So this is one of our innovation. So this is the sintering furnace. So what happens in the sintering furnace when we do sinter of the green compounds? After sintering, the furnace wall can be contaminated by the evaporating such as with lubricants, but we invent this kind of sintering furnace that sintering furnace with the de-waxing, so it mainly prevents organic vapor from conducting on the furnace wall, drastically reduce the contamination of vacuum pumps and pipeline, and extending the furnace service life. And also, this is I mentioned earlier, one-step forming production line, multiple presses. So multiple presses are connecting by a sealing channel, and then we use the automated guided vehicle to transport all the green compact to the sintering furnaces. As you see, these all are demonstrating the pressing machines. And after the pressing, during this vacuum seal tunnel, we take the green compact to the sintering furnace, and we load, we dock all the material, all the green compact in the sintering furnace, and after sintering, we will see. So after pressing the channel, here you can see the sketch of four pressing and one sintering furnace connected together. After we press here, we transport all the green compact with the automated vehicle guided vehicle to the sintering furnace, and this is actually for the large quantity manufacture. And for the smaller quantity manufacturing, we have a smaller scale, such as we connected to pressing and with the smaller furnaces. So this is the final product after sintering, and you can see the product. This is the basic overview. And here are some of our certificate also is in Chinese, but they demonstrate our how to say that. Here is some of the certificate and the patents in from global side and also from the Chinese. And that's all. It took shorter than the expected time. Anyway, if you guys have any question, you can ask, and also you can scan the codes through targets. Any question? I guess that's it. Okay, thank you everyone for your attention.